So today we will discuss about the ChemDraw software. So I would like to invite Professor Tapas Ghatak. He completed his PhD from IIT Kanpur. Then he moved to Technion, Israel. Currently, he is joined as assistant professor behind University, Vellore. His broad research area, organometallic catalysis and organometallic chemistry. So he has published a lot of good articles in reputed journals such as JACS, Organometallics, and ChemCom, etc. So it's my immense pleasure to invite Professor Tapas Ghatak. So welcome, Professor Tapas Ghatak.
Thank you, Professor Nayak, for giving the brief introductions about me, and it is my also honor to have you with you to present a very useful and important tool, we can say, that will require for research, especially in chemistry. So it's an important tool to draw the structures to present your articles, and if you want to submit the paper, it's a very essential and important tool that is called ChemDraw, or recently it is renamed as ChemBioDraw. Okay, so not only chemistry people, also physics and also biological people also can use this software for drawing different kinds of molecules, DNA, RNA, all the molecules. Okay, so this ChemDraw software is developed or designed by Party-Lenmer. Okay, it's a reputed company. Okay, so let me share the screen at first, and I want to show the icon, what is actually ChemDraw look like, right? So let me share my screen at first. Yeah, is it visible? If it is visible.
Yeah.
Is it visible? Yeah.
Yes.
So you can see here, I actually keep my, it's a very essential tool for me. So I keep it in the taskbar.
Yes, you can see in the taskbar, the second.
The second one, yeah. So I keep it in taskbar because I need it frequently. So I can just one click, I can open the software. So I'm going to do that. So just to open it, click it, and then it will open. Right?
And if we can make it shortcut in desktop, then you have to do double click.
You have to move the double left click. Okay. So let me tell you what is actually ChemDraw is all about. So ChemDraw, it's a software to draw the chemical structure, chemical compound. Okay.
And chemical reaction also you can write there, or
also yes, chemical. I'll discuss briefly. Chemical reaction also you can draw very nicely. Okay, even 3-dimensional pictures. So there are a lot of versions available till now. Okay, so update version is ChemBioDraw 16 professional one. Okay, so recently Party-Lenmer also introduced ChemBioDraw 19. Okay, it is still under progress. Maybe in this year they're going to implement it. So now the latest version is ChemBioDraw 16. So the template is look like this. So when you open this one, it will open like this, right? So it's, you can see here, this is the template where you can draw the structures. Now, so if you want to publish a paper in a specific journal, so your job is to first find out the corresponding template for that journal. So go to here, you have to go to file, and then you just go here, open style sheet. Okay, if you open style sheet, then you can see here there are a lot of styles are available based on your journal that you want to submit your paper. You can see here ACS, then advanced synthesis catalysis. Okay, journal of Chinese chemical societies, right? And if you're talking about the reputed journal like ACS, then you have here RSC1, RSC2, 1 column, 2 column. Okay, because RSC have their own template. If you want to submit your paper in their template, you can choose RSC column 2. Otherwise, you can choose just RSC column 1. Okay, then we have many other, for example, synthesis, synlet, and also Willy. Okay, so based on your choice, you can select any one and you can start drawing your structures. So for example, for my wish, I just want to select ACS document 1. So I select it. Okay, so this is the template is given by ACS, right? Now, Now let me see what are the
So I have one query. Like suppose I will take a template of ACS, but suppose my quality of the work was not so good. I unable to publish in ACS. I saw it was rejected, so I want to transfer RSC. So then that time I will face any difficulties, or again I have to redraw it.
you can smoothly transit your structure from ACS to for example, let me tell you. So this is the template ACS has given, right? So here I drawn a benzene structure. Okay, now that I want to convert it to for example RSC template, RSC column 1. So you just select this one and then you put copy. You just select copy. So my structure is copied now, right? Now go here and now you can open your, for example, I want RSC column 1. So you open RSC column 1. So this one is the RSC column 1. It's a new template open. Now you just Control V. You push Control V. Then when you put Control V, automatically it will ask you want to change the structure or you don't want to. Okay, so I want my structure should be changed. So just change the structure. If you change it, then automatically paste it in RSC column 1 format. Okay, so this is very smooth transition can happen from one journal to another journal. Okay, so let's go back to our original one. So just here, if what you have to do, if you want to don't want to the current one, current template, so just cross it, then you can already go to your other template. So this is my ACS template. Now let me see, or let me show you what are the other options that are available in file. So you can choose your template. Then is a very important options is there. You can see here. It's a very important one because when you draw a structure, your structure might be very small or structure might be very big enough, right? So it is not, maybe your structure is not you're not able to accommodate your whole structure in a simple or very small template. So what you do then? So for here, what you do then, you go to file and then you go here, document setting. Okay. Sorry. Go to file and then okay, maybe that one I'll show you a little bit later. Okay, it's a little bit advanced one. So let me tell you what are the other small options are there in file. So file, then open. You can open the previous structure, and then I told you can choose the journal template here. Then normal you can have save as all these things. If you go for save, it will save the structure in ChemDraw format, that is called .cdr format. Okay, just if you save it, it will automatically save as ChemDraw format. But if you want to save it in other format, for example in picture format, you have to select save as. So once you select save as, then you can see here your save file type. Yes, that you can choose it whatever you want. So many types are there. So many options are there. For example, I want image file, so you can choose P, can use PNG. Okay, you can use even JPEG. What are the you can see here, you can use JPEG. All these are picture format. Okay, so you can choose whatever you want. So these are the some simple options available in file. Now a very important one, that is you have to go to the next one, that is called view. Okay, so in view there are a lot of important options are there. For example, you can see here it is already checked in show crosshair. So crosshair is nothing but it will give you an idea how to draw a structure, or how big it will be, how small it will be. Okay, and you can actually fix the position of the different molecule. Okay, for example, I want to draw a simple benzene molecule. I draw it here. Now I want that simple benzene molecule should be exactly in the middle of the template. So what you do then, right? If you don't have this cross here, for example, I don't have any cross here, right? And I want that benzene should be placed exactly in the middle of the paper. Okay, so I randomly I can place it here, but I don't know whether it is exactly in the middle or not. So for this one, we have to select crosshair. So once we have the crosshair, then you can see the vertical lines and horizontal lines are available now. Now, if you want to place your benzene molecule exactly in the middle, you can see here nicely I can put it exactly in the middle. Okay, and now it is exactly in the middle of the template. So this will give you an idea about the structure of the molecule and the placement of the molecule.
And the position we can also understand from that.
Yes. Yes. So this is the role of crosshairs. Then next option is show rulers. So show rulers actually exactly similar to that we have in Microsoft Word Word options. So if you click it,
really, this is highly important to know each component, right? If you can know first of all each features, then it will be highly easy. It will be easier for all to draw the structures. So it is highly important to know all the features.
Exactly. So all these features you should know so that you can smoothly draw anything you can draw. The next option is show biopolymer toolbar. Okay,
so we will also expect, professor, from you at the end, like you publish that good articles where you draw the structures, so you can compare it from there how we can also draw here. That way we can do like any of your Jack's paper, we can take one image and we can, so then it will be really helpful that we can compare there, so that everyone get an idea. Okay, we can able to draw it all structures.
Definitely in the practice session, definitely I'll take one picture from my published paper and show you how to draw a particular structures. Okay, right. So next option is biodraw toolbar, right? Biopolymer toolbar, if you select it, you can see here a lot of options are there. AA1, DNA, RNA, you can choose, okay, whatever you want. And then the next option is general toolbar. If you select it, you can see here this toolbar will come. Here you can see, you can take a printout, you can save your structure, you can go back, you can go forward. All these general options will be there. Then we have a style toolbar. Style toolbar, you can see here, once you select the style toolbar, you are able to edit the structures. So this is a style toolbar, right? Now I want to write, for example, methane molecule. So what is the formula methane? Is CH4. So I just write CH4, but that is not the exact CH4 molecular formula. Okay, CH4. So what to do then? So first one, I want to change the font from Arial. You can see here, now it is font is Arial, but I want that font should be Calibri, right? So what you do then, you just select this one, lasso tool. If you select it, then your methyl molecule is selected. Now what you do then, you go to here there are a lot of font names are there. Okay, so you can change it whatever you want. So I want that should be Calibri, right? So go down slowly. You can see it is automatically arranged in a alphabetical manner. So go down slowly. There are a lot of options are there. I want Calibri, so select Calibri. So that is in Calibri, right? It is not even exactly what I want. So I want that, you can see here it is very small, so I want my font size a little bit big. So here the font size is 10, so you can choose it a bigger one, for example 18. I can choose 18. Once you select it, it automatically will ask you to change it. So I select it, yes. Now it's become a little bit big. It is still not the exact methane molecule, because you can see here the 4 should be in subscript. That you have to change it. So what you do then, you go here, text, okay, then you can see here whole CH4 molecule actually selected. Now whatever the change you have to made it, that portion you have to select it. So I want that 4 should be in subscript, so only 4 I should select it. So here all the methyl molecule is selected. Now I want to select only 4. So what you do, you select it. Okay, now you can see here it is already selected with the green color, blue color. Now come here. Okay, there are a lot of options are there. It's a superscript, it's a subscript. So select it here. Now you can see here a methane molecule become exactly a methyl molecule. Okay, so in this way you can draw a molecule. Now if you
And
want
if
to draw
we
a,
want color change, also we can do it with this, or no, this tool.
yes, I'm going to show you some color change also. So I want that methyl molecule, I should remove the methyl molecule. So here we have eraser options. Go here and just erase it. Okay, now we want to draw a little bit another molecule, for example ammonia. Okay, so just write NH3. Right, now I want again 3 should be in subscript, so put it here. Now you can see here we have nitrogen atom and we have hydrogen atom, right? And I want that 2 different atoms would have different color. So what you do then? Okay, so I want the nitrogen should be in blue color. So you select here and then we have a color template. Okay, you can see here colors. So there is a small triangle is there. You just select on there. If you select it, or if you just press the button, yes, if you press it, then this will come. Right, now I want the nitrogen should be in blue color, so you select blue color. Okay, if you want different color, then you can have a lot of options. So go other, and then all the template color template will open, and you can choose whatever you want. Right, so I want nitrogen should be in blue color. I select blue color, and then hydrogen, I want hydrogen should be in magenta color. So you can see here we have pink color, we select it. So in this way you can choose any color for any atom. Okay, so this is the way to draw a simple molecule. Right, now I want to draw the structures or a simple chemical reactions. For example, I
So
want
in
that
this tool is the name is style toolbar. That is a important tool
is a
for
very,
ChemDraw.
yeah,
So this is an
so this one
important.
actually, yeah, you can see here this is actually show style toolbar. So this is a style toolbar. You have a lot of options in style toolbar. Okay, so let me in subsequent slides or subsequent video we're going to show you the different options that we have in style toolbar. So now I'm going to show you how to draw a chemical reactions. For example, I want that hydrogen and nitrogen will react to form ammonia, right? So hydrogen, you should select caps. So your hydrogen will comes as a caps. Now H2, right? Hydrogen plus. So I'm just selecting this text toolbar. Okay, so here once you select it, the text toolbar will come, and then I'm going to write it. So hydrogen I have written, then hydrogen plus nitrogen. So you put plus from your keyboard. Okay, and then put a space, and then you select N2, put N2. Okay, so this is a reactant, right? And again, the hydrogen and H2 and N2 is not in proper position. So select 2, place it in subscript. Again, select N2, place it in subscript. So this is a reactant is ready. If you want that you want to write the stoichiometric exact stoichiometry of the reaction, then you can have a balanced reaction. For example, I want the nitrogen should be in 3, so you can just uh, place 3. Okay, so you can see here 1 hydrogen molecule plus 3 hydrogen molecule, then we are going to form ammonia. Okay, so here this is a reactant. Now
Arrow mark we need. So arrow mark I can't able to find. Is there a
yes,
arrow mark we can able to get here?
yes, yeah. So that I'm going to show it. So now we have to put a arrow, or you have to place a arrow. So here you can see here you can see the options is written arrows. Okay, a
Yes.
lot of options are there, different types of arrows are there. For example, what are the options available in arrows? To see it, you can just click on the small triangle there, you click it, and then you select it. Right, you can see there are a lot of options are there, different arrows, different shapes arrows. It can be double head arrow, it can be single head arrow, it can be reversible arrow. So whatever you want, you can select it. So I want a straight, simple straight arrow, the smaller version. So select this one. Okay, if I select it, then you just draw it. Simply just draw it like this. Okay, so it is done. Now my reactants are ready. It is going to convert to the product. So I need to write the product, that is ammonia. So again select text, and then here you write NH3. Okay, so in this way you can write ammonia. Now you can see what are the necessary of having crosshair. I told you that crosshair will tell you the exact position of the molecule, right? So you can see here, although I have drawn hydrogen plus nitrogen equals to ammonia, but you can see it carefully. This ammonia is not placed properly, right? It is little bit, above the arrow. It is not in a same line. Nitrogen, hydrogen, and ammonia not in same line. So what to do then? Okay, with a naked eye is not, it is very difficult to find it out. So what you do then? So you just select all the molecule, okay, and then just place it on the solid line. You can see here, if you place it on the solid line, you can easily find it out that your nitrogen, hydrogen, and ammonia is not in the same line.
Yes.
So you see ammonia a little bit above the line. So just select ammonia and place it in a proper position like this. Now exactly hydrogen, nitrogen, and ammonia are in a proper positions, right? So in this way you can draw a simple reactions. Okay, so my reaction is ready. Now you can place like this, and if you want to copy this structure or copy this reaction to your Word documents, what you do, you select it, then copy. Okay, copy it, and then you have to open your Microsoft Word. So I'm just going to open my Microsoft Word, any file. Yeah, so I'm going to open it. So although my Microsoft Word is a little bit older version, you should have the new one, 2019. So my Microsoft Word is open. Now, once you open it, you just put Ctrl V. Once you put Ctrl V, now it is, see, it is placed in your Word, right? Now, once you open the Word or you place it in the Word, you can close the ChemDraw file without even saving. You can do that. For example, I don't want to save it. I just close it. Okay, it's not saved, but it is saved. Whatever the file you created in Word, that is open. Now, maybe you forgot to save your ChemDraw file, right? You are not able to save it in a proper time. So what you do then? But you have this Word file, so don't worry about that. So just what you do, you just make a double click. Okay. Once you make a double click, you can see it is trying to connect with the ChemDraw file. It will take some time. So you can see here, once you double click it, is nicely open your ChemDraw file. So you don't need to save it. Okay, you draw the structure, you place the structure, you put it the structure in Word file, and then you don't need to save it because Word file automatically saving your ChemDraw file, right? So I want my style should be in ACS. So I'm going to convert it to ACS document. Okay, then Control V. I don't want to change it, so don't change the setting. Look like this. I want a little bit big in size, so I want Arial, and then my font should be 60. Okay, yeah. So this is done. So in this way, you can draw a simple chemical reactions. Now, what are the other options?
If we do, Professor, if this thing, we will take like we take in a Word file. But if we do in PowerPoint, that also possible it will come?
Excellent question. Excellent question. So let me close the Word file. You close your Word file. Don't save it. It's fine. Don't need to save it. Now, as Professor asked me a question that I want this structure should be placed in PowerPoint. So you just open your PowerPoint. Okay. You open your PowerPoint and then Control V. You just put Control V. You see here, the structure is placed. And even it is saved in as ChemDraw file. So you can easily close the ChemDraw file without saving. Okay, but you have to be sure that either it should be saved in doc file or PPT file. So my PPT file is open now. So I want to go back to ChemDraw file. So what you do, you just put a double click. It will take some time to go back to the original ChemDraw file. Yeah, so you can see here it nicely went back to ChemDraw file, right? So this is the way to place your structure in your doc file or PPT file. So what are the other options are there? Let me see. So this is the text file, text options. You can write anything from there. So here that is multiple bond, because sometimes as a chemist we need to draw single bond, double bond, triple bond. So there are a lot of options are there. What are the options available? You can see here. Just select it, and then you can see here we have this many options. We have double bond, we have partial double bond, then cross. Okay, we have triple bond, we have quadruple bonds. Okay, so these are the different bond options are there. You can choose whatever you want. Then we have a dash option. For example, I want that two atoms should be connected with a dash bond, not a proper solid bond. For example, I just write n. Okay, and the two n atoms, I write another n. Okay, and that two n atoms maybe I want should be connected with a not proper single bond, but it will be connected to a dash bond. So what you do, you select dash, and then what you do, you just come or select on nitrogen from where you want to draw the dash bond. So if you put the cursor on that particular atom, you can see here it automatically gets selected and it is appearing as blue selections, right? And then from here you just draw the dash bond up to the second nitrogen. Now this software is beautifully designed. You can see here, if you draw nitrogen with a dash bond, it will automatically taking NH2. So there is there is a logic behind that, because two nitrogen cannot live like this. It has to have some other atom connectivity, right? So its system is automatically taking two hydrogen to satisfy its valency. Okay, so if you miss any valency, mistakenly you don't mistakenly you just forget to mention the valency of a particular atom, you don't need to worry about the automatically the software will remind you, or software automatically place the proper valency. So you can see here nitrogen NH2. So now all the three valency of nitrogen is satisfied. So this is the utility of dash line. Now for example, there are some options are there. You can see here, you can Hertz bond, right? Or you can see here, this is Hertz wave bond. What is that? For example, you want to draw a stereogenic center. For example, I want a carbon, and it should be a tetrahedral shape. So what you do then, you just place two solid bond, and then I want the other bond should be solid, dash solid or solid. Okay, so what you do, there are two options are there. This is the dash solid. Okay, so you select it, and then you select like this. That means the hydrogen actually placed below the plane, right? And you can take the solid one, and then you again draw it like this. That means there are four hydrogen attached with carbon, and all are different stereo in different positions. So these two hydrogen are in a same plane, and this hydrogen with a dash bond are in a below of the plane, and these hydrogen are above the plane. So in this way you can use the dash bond and solid bond, right? And what are the other options? You can see here we have orbitals. Okay, here are different types of orbitals. You can see we have p orbitals. Okay, we have different types of p orbitals, d orbitals. You can see here d orbital, dz square, dx square minus y square. Okay, d xy, dyz, and dzx. You can select any one as your choice. So so these are the different options are there in style toolbar. Now specifically if you want to see some three-dimensional picture. For example, methane molecule. I just draw CH4. Okay, and you want to show that how methane molecule actually look like, right? So methane molecule, you know that it's a tetrahedral molecule, you know that. But if you don't know that for a unknown structure, and that you want to know that what is the structure of that molecule, you can easily do it in ChemDraw. So what you do then, you just select the molecule and then you go to view options, right? And then there's option one, the option is there, it's called show Chem 3D. So select it. If you select it, then you can see here another window will open here, and nicely you can see your methane molecule actually a tetrahedral molecule. So this is the three-dimensional picture of your simple molecule. So if you don't know the structure or exact structure of your unknown molecule, you can easily able to find out what is the exact structure of the molecule.
So
by
if we want to take this one to our Word file or PPT, whether we can take this?
Yes, you can do that. You can just import it from here to your ChemDraw file, from your Word file or your PPT file, that you can do. Okay, I'll show you how to do that later. Yeah. Okay, so this is my screen. As I told you, I actually keep my ChemDraw in taskbar. Just select it, and now this is open. So what I want actually, I told you, once it open, I feel that this template is a little bit short for me. It's not very big enough. So I want a little bit big template. So go here, file, and then one option is there that is called page setup. You go here, simply select it here. Now when you open it, you can select, you can see a lot of options are there, right? First option is size, so it is automatically selected as a letter. Okay, if you drop it down, then there are a lot of options are there, B2, B4, just like your normal page size. Your then A4, this is nothing but A4 sheet size. Okay, so these are the different options are there. Okay, and I want my page little bit big, will be little bit big enough, so I choose legal. Okay, so legal actually is big enough, right? So you select legal, and then I select landscape. You select it here, then you put OK. Once you put it, then you can see here it is converted all the template to the window, right? It is covering all the windows. Okay, so now the space is big. You can draw whatever you want, whatever you want to draw, you can draw it. Even if your structure is very big, you can easily accommodate in the page, right? So let's start it from where actually is pause in last video. So here, view. So what are the options are there in view, right? So I told you that we have styles option, then object toolbar I told you, the structure toolbar I told you. Then we have a very beautiful options is there that is called periodic table. For example, I told you you can write whatever you want, any atom, any molecule, right? You can write it, or even for atom, you can actually select it from periodic table, right? So you can see here we have option show periodic table window. You select it, and then the periodic table is open to you, right? And then from here, whatever atom you want, you can select it, and you can draw whatever you want. For example, I want a copper bond, right? So what you want to draw copper bond. So you select here. I can see a copper molecule, copper atom is here. You select here, then just click on here. You can see here already automatically copper came, right? And I want that copper should be a little bit big in size. So again, you go to lasso tool, and then you will select a little bit larger font size. So now it is 16. I want another copper. So again, I make a bond between copper and copper. So I select single bond, and then you go here. Okay, I want another copper should be there. So select copper, and yeah, I want that copper should be placed exactly on the bond. So once you come near to the bond, you have to come such a way that one bond open that should be in blue color. Okay, so come here, and then you can see here, once you come close enough to the bond become blue. Okay, then you click it. You can see here I put copper. So whatever atom you want, you can choose it from periodic table. Either you can write it or you can choose it from the periodic table. Okay, so this is the role of periodic table. Now, what are the other options are there? You can see. Here we have another important option that is called character map window. Okay, so if you open it, you can see here is character map window is open now. So what is actually it contain? It contain all the alphabets. You can see here 0, 1, 2, 3, all the digits are available here. Okay, you can have, you know, alpha, beta, gamma, all these things. If you want to select it, you can do that. For example, I want to write alpha. So what you do then? You just select A, text, that is A, you write it here, and then I want to write alpha. So here you can see here, we have alpha. So go here and then select it. It's automatically came as alpha. So from character window, you can choose lot of things. You can see here others option. You can select right. Okay, that is root. Then caps A, caps B, X, then thermal delta. Okay, then you can see here M, N. Okay, you can have different kind of box, different arrows, right? Up arrow, down arrow, okay, right arrow, left arrow. All these options are there in character window. You can choose whatever you want. Then what are the next options is available here? Template. Okay, so it's a very nice options that we have in view. So here, once you select or you click on template, you actually open different options. You can see here what are the options are available here. You have advanced bio draw. Okay, you can draw a little bit complex biomolecule here. You can draw amino acids. If you select it, you can see here automatically the system will give you a lot of options. All the amino acid options will give you. Okay, you can select whatever you want. You don't need to draw it actually. You can actually select it and you can place it in your ChemDraw file. For example, I want this one. Okay, right. So select it and then just click it. You can see here. Yes. I just get it from amino acid template. Then what are other templates are available? You can see here amino acid. Then anatomy, animals, even you can see here. If you select it, you can see here all the animals are there. Okay, you can pick whatever you want. Animals, bird, okay, reptiles, all options are there. Then aromatics. Okay, for example, we have a lot of aromatic ring. You can see if you select it, these are the aromatic options are there. Okay, you can choose whatever you want. You don't need to draw it. You just select it. For example, I want biphenyl. Just select it, biphenyl. Right. I want naphthalene. Select naphthalene. Click it. I can get whatever I want. I want, you know, Buckminster fluorine. You can see it here.
Yes.
You see it. Okay. I want porphyrin. You can see it. It's a very complex molecule, porphyrin, right? So I don't need to draw it. You just select it and click it. I have the porphyrin molecule.
So, okay, Professor, this fullerene structure, suppose I want to see like the visualization of CH4. Similarly, if I want to see this fullerene structure also there, is it possible to see the 3D view of this?
Yeah, of course. Let me see it. Let me see it. How fullerene molecule actually look like, right? So you can see here in my template, I have different molecules. I have biphenyl, I have phenyl, I have porphyrin, I have copper, then I have one amino acids. I want Buckminster fluorine. I want to see only Buckminster fluorine in 3D view. So what do you do then? Okay, selectively you have to select fluorine. So you just click on lasso tool and then you select fluorine. Okay, buckable, and then you go to view options and so Chem 3D. Click it here. You can see here.
Oh, why it is not coming like a bulkable, like here you can see it?
Because you can see here maybe all the atoms in the molecule, vacuole molecule, whatever actually system is drawing,
yes,
is
maybe the draw
not
in this
sp2
way.
hybridized.
Yes,
It's
yes,
not sp2 hybridized.
yes.
Okay,
So
all
then
the
it does
bonds are
draw
actually
it.
not properly given.
Yes, yes. But if we will draw, then definitely maybe we can able to see this.
Yes, if you place the double bond in a proper place, if you make all the carbon in sp2 hybridized in Buckyball, then it will be look like a beautiful real Buckyball structure.
Yes, yes.
Okay, right. Then what are the other options in there in template? You can see animals, aromatics, then bicyclics. If you select it, you can see here a lot of bicycles. I mean, two cycles are joined. Okay, they actually two cycles actually shared a bond. You can see here we have a 6-member ring, 4-member ring. We have a 6-member ring, 5-member ring together. Okay, you just select it whatever you want. It's called bicyclic system, right? So you can select any one that you actually want to draw. Then these are the different options are there. There's CP ring, okay. Then a DNA template, then hexose, for example, glucose molecule, okay. You can select whatever you want. There are a lot of glucose molecules are there, okay. Even you can see the options is already there, okay. So you can select whatever you want in your paper. You can select it as it is from the system. Okay, then hexose are there, hexose, then nanotubes. Even you can draw the nanotubes. You can see here. These are the different nanotubes. Okay, just let's try to see the nanotubes in 3D. Let's see how it look like. Okay, so this is nanotube. I select first one. So this is
armchair
molecule. Okay, so let's see how it look like in real 3 dimensions. Okay, so you select it, then let's see how it look like. Go to view and 3D. You see
yes,
here.
this is okay. This is
Nicely it
completely
is showing the
yes,
nanotubes.
very nicely presented.
Nicely it is showing nanotubes.
Yes, yes.
Okay. So this is very beautiful options. Okay. So you don't need to draw.
If we want to take this one also, and we can also take it like here
you
also
can import
copy
it.
and paste same way, or
yes, 3-dimensional picture. I will show you in the next video how to import the 3-dimensional pictures in your paper directly. That you can do. Okay. So these are the templates available. Then metallocene, right? For example, we have very well-known, a very famous metallocene is ferrocenes. So here you can see there are different metallocenes options are there. You can choose whatever you want. For example, I want ferrocene. Okay, so select this one. Okay, so you know the ferrocene, the metal is actually iron. So it is in general it is written as M. So you want to replace it with iron. So what you do then? You can write as it is Fe, or you want to write from the system itself. So go here and then insert periodic table. Okay, and then you select iron. Okay, so you can select. So it's automatically came. So in this way, you can also write or draw different sandwich molecule. And then metallocenes, and then microorganism. Let's see what are the options are there. You can see here. These are the different microorganism. Okay, we have also coronavirus. You can see here.
yes,
you can see here. It looks like a coronavirus. I don't know. Maybe, yeah. It looks like a coronavirus. Okay. You can see here. Professor, is it coronavirus?
yes.
It looks like, right?
It looks like coronavirus. We can 3D also. I think it is in 3D. It looks like
how it
3D.
looks like. Yeah, let's look like how it looked like in 3D. No, it's not able to, because there's no real atoms are there. There's no atoms. So 3D can actually convert atom to the 3 dimension. So there is no atom.
Yes.
Okay, that's why it's not able to convert it. I hope so. Okay, so go to view. Let's see what are the other interesting features are there in view.
Template.
So we have nanotubes, we have organelles, pH rings, polyhedra. Okay, you can see here what are the polyhedra I told you. You can have different polyhedra, tetrahedral, octahedral, okay, the icosahedrals, all the polyhedra. You don't need to draw it. System is automatically giving you the options, different polyhedra options, right? And then pH ring, polyhedra, then polypeptides. Okay, if you are a bioinorganic chemist or bioorganic chemist, you need to draw this different polypeptides. You don't need to draw it. You can select it from the system itself. So these are the different options are there in view, right? Now come to the next one, that is called objects. Okay, so there are also a few interesting features are there in object. For example, first one is object setting. What do you actually mean that? Object setting, for example, I draw a simple methane molecule. Let me remove all the things. If you want to remove all the things, just select Ctrl A, it will be selected, then press delete. Automatically delete all the things, existing things. Now I want a methane molecule, simple methane molecule. So what you do, carbon, and then you put like this for hydrogen. Now you can see here, I actually drawn it incorrect way. You can see all the bonds are actually different size. Okay, if you want to do it manually, of course you will have some mistakes. Okay, you cannot put a measured bond distance if you draw it manually. So for this, system actually give you one options. You don't need to draw it manually. So what you do then, go to objects and select fixed length. Okay, so just select fixed length. If you select fixed length, then what you do, I want to draw methane molecule. Then if you select fixed length, now it is automatically, you can see, it's automatically select fixed length, right? It is already clicked. Now I want a bond. So what you do, I make a bond here. If you want to make a bond here, as the system automatically fixes fixed length, you cannot increase the bond length. It automatically takes whatever actually system actually prefer. Okay, so in that case, all the bonds should be in a same length. Okay, you don't need to worry about that. You can see here, even if you want to increase it, you cannot increase it. So this is the role of fixed length. Okay, you cannot increase the bond length, but if you want, the bond should be different length, then again you go to objects and remove the fixed length options, and then if you want to draw, you can draw whatever you want. You can see here, I can draw a very big line. Okay, so this is the role of fixed length.
Fixed length, if suppose I want little bigger size but fix all, but little big means length little more I want. So that also you can do.
You want a big length or big thickness? Little bit more thickness.
More, big length.
Yeah, so in that case you have to unselect the fixed length option. You see, okay. You see here, there is no selected. It is unselected, right? Fixed length. Now you can draw whatever you want. Your length should be whatever you want. You can draw. Just you select it, and then you can see here, I can draw whatever you want.
Yes.
The length. Okay. Now what are other options there? Fixed length, then fixed angle also. Okay. If you want exactly your methane molecule should be tetrahedral, then angle should be 109 degree. Okay, so you can actually fix the angle like this. Okay, so stereochemistry, you can see the stereochemistry, align and distribute, all these things are there in object setting. Okay, for example, again, I want ammonia molecule, right? Draw here ammonia molecule. Okay, so I put in, and then you connect it on the hydrogens. Okay, so this is NH3, but still it is not completed. I put NH3, but the ammonia actually is not ammonia, it's NH3. But if you put a lone pair on nitrogen, that is a complete ammonia molecule. So from where you import a lone pair of electrons. So you can see here, we have options here that is called chemical symbols. Okay, you just select it here. Once you select chemical symbols, okay, and what are the options are there? You can see here, we have a positive charge. If you want to create a positive charge, you can select it. Positive charge in circle, positive charge, a discrete positive charge, then a cationic radicals. You can select a radical with positive charge. Then you can see here a lone pair. Okay, if you select it, I want to put on nitrogen, so come close to nitrogen and select it. You can see here I put nitrogen with lone pair. Okay, then your lone pair is moving. You can select these options. Then you want to put a negative charge with circle. You can see here this one. I want that ammonium ion. Okay, so what you do then? I need ammonium ion, so NH4. I put NH4. You have to remove the lone pair. I remove lone pair, and then I put NH4. But you know that in ammonium ion, the nitrogen is actually positively charged. So what you do then? You select positive charge, right? And then you come close to nitrogen. You can see here when you select nitrogen or put your cursor on nitrogen, it's become blue. Then you click it. You can see here. So you can actually relocate the positive charge. Select it from here, and then you can place it in the suitable positions. So now you can see here ammonium actually is a NH4 plus ion. So in this way you can use the positive charge, negative charge, then radical cation, radical anion, okay, carbon ion, carbocation, all these options are there. Then we have a dash bond, we have a wave bonds. Okay, here we have different other heterocycle. We have cyclopropane, cyclobutane, cyclopentane, cyclohexane, cycloheptane. Even you can draw the different chair conformer of cyclohexane. For example, this one. You can see here, you don't need to draw the chair conformer by your own. You can select it from the system. You can see here, this is the chair conformer of the cyclohexanes. Okay, so these are the options are there in main toolbar. It is a very style toolbar. It is a very useful tool. Okay, then object is finished. Then I want to show you another interesting feature that is called, I told you that I draw an ammonia molecule. Now selectively, if I want that one of the bonds should be a little bit thick in size, then what you do? Selectively, you don't want all the bonds should be thick in size, only one bond should be a little bit different from other. Then what you do? You select this bond, any one bond that you want to do it, you can select that bond, right? And then you right click on there. So I do the right click here. Once you do a right click, then you can see here a lot of options are there. You can change this bond single to double. Single bond, it can be plain, it can be dash, it can be highest. Okay, for example, if you want to make a dash bond, just select dash bond. You can see here it's converted to dash bond. Okay, so I want it should be single properly, so it is plain single bond. Okay, you right click on there and let's see what are the other options are there. Single bond, double bond, you can convert single bond to double bond. For example, you select it plain, you can see here I convert nitrogen had a double bond. Okay, we are drawing, so I want should be single plain bond. And then what are other options are there? Let's see. Double bond, you can make a triple bond, quadruple bond. Okay, then bond position you can change it, bond properties you can change it, alter it, and then one option is there that is called object setting. Okay, you just go to object setting. Now once you go to object setting, you can actually edit the bond property, right? For example, a lot of options are there. You can change the line width, you can change the bold width, margin width, and hash spacing, right? So automatically when you draw a bond, system will tell you, or system actually select the bond which should be 0.0 to 1 centimeter. But I want a little bit thick, so you can change it whatever you want. For example, I want should be 5.2. Okay, so I select 5.2, then do it, select it, write it, and then put okay. You can see here only one bond. Actually you can selectively make it little bit thick or thin, whatever you want. Okay, not only that, for example, you want to do it in an arrow. You draw an arrow, and then I want that arrow should be little bit thick in size. Okay, so select it and then right click on that and go to again object setting. Whatever the changes you want to do it, you have to go to the object setting options. So go to object setting. Once you select it, then this option will open. Line width, then bold width, all these things. I told you system automatically give you the options to 0.0 to 1 centimeter. Okay, and that you can do it, or you can edit it. For example, I want 5.1. Okay, do it. You can see here now it's become a little bit thick.
Yes.
In this way you can edit the bond, you can edit the arrow, or you can edit your structures, whatever you want. Okay, for example, selectively you want any one of the bond little bit, you know, it should be white bond. Then you select here this one. Then just right click on there. You select it and then right click. I want the bond should be changed to this one. Select it and then place it on that bond. You automatically the bond will change. Okay, this way beautifully we can draw your molecule whatever you want. Right, and another interesting feature that I'm going to tell you. That I'm going to tell you. For example, let me see it. Let's say write benzene. I write benzene. Okay, and I want the formula benzene. Okay, if you don't know the formula of a molecule, you just write it. So in a system, it has some well-known molecules with the molecular formula. It should be well-known. If you just write it randomly, it will not able to give you. Okay, if the molecule is very common or normal, then system will give you the exact molecular formula. For example, benzene. Okay, I want the formula of benzene. So what you do, you write benzene, then you click it, you select it, then you go to structures. Then you can see here one option is there, name to structure. You select it.
I think benzene spelling, that's why it's not taking.
Okay, yeah, basically BENZENE. I think it's BENZENE is correct.
Yes.
Let's see. You can see here.
Yes.
System is actually giving benzene structures. So if you don't know the structures, you can just write the molecule name and then you can convert it to structures. But you have to be sure to explain about 3D versions of ChemDraw. Okay, so what to open it? So for this you have to go to view. Okay, there are is the main features, and then go to view, and then you click on show Chem 3D hot link window. Okay, just click it.
Yes.
So once you click it, then another sub window will open on your main window, right? So this is the 3D window, right? Now if you draw something, for example, I will draw maybe a simple molecule starting with benzene. So this is a benzene molecule. So once you open it in a benzene molecule, or draw a benzene molecule in your main ChemDraw template, you automatically you can see the molecule in 3D. So actually 3D molecule in 3D view, you can see the molecular, molecular image. So to just magnify the pictures, or maybe you can open this 3D view throughout your whole screen. So for this, you have to just click on here. That is launch Chem 3D. Just click on here. Okay. So once you click it takes some time. Yeah. So now it is open, right? Can you able to see it?
Yes.
So now you can rotate it. So you can see here where we have options to rotate it. Just click it, and then you can rotate the molecule, and you can really see the structure of the molecule. If you even don't have any idea about a new molecule, you can draw it in ChemDraw, and you can have some idea about the molecular structure or real molecular structure in practical by these features, ChemDraw 3D features. Okay. Now, if you want to add some bond, for example, I just want to add one bond or maybe one functional group in benzene. So just you click on here, you select bond, then you click on here. So this is actually nothing but toluene molecule, right? So just you click on here. So just I add one methyl group, and you can see we get toluene molecule, and this look like this. Okay, so this is the real picture or real three-dimensional picture of toluene molecule. Okay, so in this way you can have idea about unknown molecule, even the known molecule. Okay, so this way you can have some idea. Now, if you import this picture to your paper or in your PowerPoint presentations or anywhere, so how to do that? Okay, so for this you have to go to file. It's a simple thing. Just you have to go to file and then save copy as. Okay, just click it here, and then it will open some options in which format you want to save it. Okay, so based on your wish, you can select any one. I want to save this picture as JPEG. Okay, so a JPEG or PNG, whatever. I want to save it as JPEG, so I save it as JPEG, and then you just select the locations. I want to save it in desktop. Just click on save. Okay, so now it is saved already. So let me open the picture, how it actually look like. Even you can, change the background and all this thing. I'll show you how to do that. Okay, so
we can also change the background of that one.
Background also you can change it.
Okay.
So this is the picture look like. Let's open in picture format. Okay, so if you open it like this, you can see here. This is the picture format. Now, is this picture you can use it for your paper or wherever you want. You can do that. Right? Now, if you don't like this background, if you want to change the background, you can do that. So you can see here there is options, background color. Okay, so if you click it, then it will show the color options. You can choose whatever you want. Okay, if you want even white, you can use it white. If you want
if you know
gray,
background,
this is this
no
I select gray color. It's a gray color or no background. It's look like this. If you select this color, black color, look like this. Okay, so in this way you can change the background, and there are other options also. For example, spin option. If you click it, you can see here the molecule automatically will spin it. You can see the molecule is moving, rotating. Okay, you can spin it clockwise or anti-clockwise. This. Okay, you see here. I click it. You can see it. Now it is moving in other directions. Okay, so this is the feature. It's a very beautiful and very useful feature. You can imply it for your research article or maybe your presentation, scientific presentations. Okay, so this is a little bit advanced technique.
In this format, can we can make, suppose you want to make a video of this one to present, so that is also possible? Or I
think you can, yes, I think you can save it as video file also.
Okay.
Save copy as. I think you can save it. If there are some options, I think you can save it as video file also. Okay, you can see here AVI movie. You can see here
Yes.
AVI movie. Okay, so
Ah,
let's select it. Let's select it. Let's see how it's actually look like. Save it. Demo is in progress. Please stop the demo and save the file again. Okay, so I think I don't know why it is showing like that, but I think you can save it as video file also. You can try it, right? So this is some advanced features of ChemDraw. Now let me go back to the basic features.
yes. I
Okay,
think last
how
class we
can
stop here. I think that how we can take the image from 3D image, how we can import that or export that. So we stopped last class. So we clear about that how we can take, how we can export the
picture to your
picture. Yes.
Word file or
Video.
even PPT file.
Yes.
Okay, you can do that. Yeah, now I come back to the original ChemDraw feature. Now let me show you how to draw some, little bit complicated pictures.
Yes.
Okay, so for this, let me open one of the paper,
Yes.
and then I can copy it from here actually. Okay, for example, I want to draw this compound. Maybe this compound. Okay, so what I do, I just take a snapshot. Okay, this is Adobe Acrobat Pro, so I can take a snapshot. Okay, so I select the pictures and then take a snapshot. I take the snapshot. Okay, and then you go back to your original ChemDraw. This is the original ChemDraw. Now I feel this window is not sufficient to draw the structure, so I want to expand it, or I want to enlarge the setup. So what you do, you go to page setup. Okay, and then you choose landscape, and then legal. Okay, if you select it, then you can see here your actually windows become a little bit large. Okay, now it is enough to draw the structure. So just you do Control V. Okay, so now you can see here this picture, you can take it directly from the paper. Okay, I put it because I want to draw the structure. Without seeing the structure, I'm not able to draw the structure. That's why I actually copy the picture and put it in my ChemDraw file. Okay, now I can look at the picture and I can draw it accordingly. So for this picture or this compound, maybe I can start with from here in the corner. Okay, so we have a cyclohexane molecule, so that is already have it in the template. You choose it here. Okay, now you can see the cyclohexane actually it is in other mode. So what you do, you just select the pictures and you can rotate it. So in this way you can rotate the molecule nicely. Okay, yeah, so that is done. So I drawn this portion. Now we have a double bond. You can see we have double bond. So ChemDraw already had double bond, so you just select it, and then where you want to draw the double bond, you just bring your cursor there and just put a right click or click one click. Okay, now I want to put oxygen. So go here, text, and then I want to put oxygen here. So bring your cursor exactly on that position, click it. Now nicely you write oxygen. So draw oxygen is drawn. Now I want to draw this portion. So you can see here we have a thick bond. So here also you have a thick bond. We select it, and then you click it here. Okay. Now after that we have a benzene molecule. So nothing to worry about. We just select benzene molecule, and then we just click it here. Bring your cursor in the correct position and click it. Okay, so you got the benzene molecule. Then again we have one single bond,
and oxygen
automatically oxygen is attached. So we just select single bond and you click it this position. Okay, then again we have another oxygen. So bring your cursor there and just from the keyboard you type O. This. Okay. Again, we have a CH2 linkage. So again, you select the bond, and then what you do, if you click it, then what will happen? The system will, choose the orientation of the bond, right?
Yes.
So if you want to do by yourself, then don't click it. Then what you do, you just draw it. So let me remove the bond first, and then what you do, you don't click it. You just select the bond, and then you draw the bond like this, according to the pictures. I can draw it. Okay, this one.
Okay.
If you click it, then what will happen? System will automatically, choose the orientation of the bond. If I don't want that orientations, then you have to draw the bond. Okay. And draw is nothing. You just extend the bond. You select the bond type and then extend it. Then again, you can see here it is a little bit disorientation. If you click it, then what will happen? Let me show you at first what system actually want. If you click it, yeah, system will you giving the same options that we have it in the picture. So it's fine. I can choose it. Now we have one cyclopentane type ring. So you have it in here. So you select it and then you click it here. Now you have to give the
nitrogen
bond.
nitrogen.
At first you put nitrogen in a respective position. So again, you have to select text, and then you have to bring your cursor on that position, and from the keyboard you just type capital N, one position, capital N, second position, and again capital N, third positions.
Yes.
So nitrogen is done. Now we have to put the bonds, right? So first we have to put the double bond. So again, what you do, you can select the single bond and you just click. You just click where you want to put a double bond. Okay, so I bring my cursor here. I want to put a double bond here. So just bring your cursor that position and then click it. Then automatically you can put one double bond. Okay, we have another double bond in this position between two nitrogen. So bring your cursor exactly on that position, and then this ring a little bit small. So make it a little bit large to see the bond clearly. Okay, so select it and then you expand it like this. Okay, expand it. This is very easy to handle. ChemDraw software. It's very user friendly. Okay, now we can see the bonds clearly. So select the single bond again, and then you bring your cursor here. Again, it is very difficult to select the bond because your nitrogen is too large. I'm not able to select the bond between two nitrogen atoms. So what you do, you extend the ring. I hope it is fine now. Okay, so I want to put a double bond between two nitrogen. So bring your cursor in the position and then click it. You can see here, I can put double bond. Now, if you want to switch the size of the ring, again you select the ring. Okay, because why I want to switch, because you can see here the two ring, benzene ring, and to this cyclohexane ring is a little bit smaller compared to this cyclopentane ring. So what you do then, you just select it and then squeeze it. It brings to its original positions. Okay, now again from there I need another bond from nitrogen. You just click it. You can see here, if you click it, then system is actually taking the bond little bit inclined way. So I don't want that. So what you do then, you just remove it, or even you can bring it to the original position. For that, what you do, you just select on the one terminal of the bond. Then you can see once you select it, one this kind of cursor will appear. It's a hand type cursor. Then you just hold it and then bring it down nicely. Now my bond is a little bit or exactly on the same position that I actually want. Okay, now you click another time. Is exactly taking as the paper is presented. So again, I want to put this benzene ring. You select benzene ring from the system.
Yes, we can take directly there.
In this way, you can see here, I actually replicate the molecule that is there in the paper.
Yes.
In this way, you can nicely draw many complex structure. Even whatever you want, you can draw from ChemDraw. Okay, so this is one type of things you can draw it. Another thing, if you want to, for example, if you want to draw the catalysis cycle, okay, how can I do that? For example, I can show you some catalysis cycle, and then I'll tell you how to draw the catalysis cycle, because that is very important, because many chemists actually doing the catalysis reactions, and they frequently they need to draw catalysis cycle. So it is very useful to know how to draw the catalysis cycle. Okay, so let me open one catalysis cycle. I have it in my paper, I think. Just a minute. I have really a cycle, so I have it. Just a minute, I have it. Yes, this is the one. This is the one that I want. Yeah. Yeah, it's
Yes.
exactly a cycle that I want to draw. So you can see here. Okay, you can see in the picture. Is it visible, guys?
Yes, yes.
So you can see here. This is the catalyst cycle, and you can see in the cycle I beautifully draw the exactly circular shape arrow. Can you see it? It's exactly circular shape arrow.
Yes.
Exact circle. So how can you do that? Okay, it's very difficult to draw it. So let me tell you how to do that. So what you do then, you open your ChemDraw, and then here one option is there. You can see here, this is drawing elements. That option is there. You just click it. Okay, once you click it, then it will open many options. You can see here we have many options. Yes. Right? So you select circle. Then you draw it here. Whatever shape you want, you draw it. For example, I need this shape, so you draw it here like exactly. And then I need to put arrow, exactly bent arrow. Okay, so what you do then, you go to here, and then you select arrow. For example, I need this arrow. Then you draw arrow like this. Okay, now I need to bend it. Okay, so what you do then, you can see here, once you touch on the middle portion of the arrow, you can see here, I'm just touching on the middle portion of the arrow, then you can see that it actually, I can see the type of arrow, it is actually, double-headed arrow. So you can see this one. My cursor became double-headed arrow. That means you can bend the arrow from that position. So what you do, okay. I want to bend it, so I'm bending it here. You can just hold your mouse, left key, and then you bend it like this. How much bend you want? Okay. You have to have an exact idea. So you bring it on the circle here, and then try to fit it on the circle. You see, my arrow is not properly fit into the circle. So what you do then, you just hold it and try to match it on the circle. You can see it. Okay, now this properly fit on the circle. Okay, so once arrow is done, you take another arrow. Okay, just draw another arrow, and then again I want to put it exactly that position. So you just make a straight, and then you come to middle portion of the arrow. You can see here the cursor become double-headed arrow. Now from there you try to bend the arrow like this. You can see here. And how much you need for that purpose, you just bring the arrow exactly on the circle. I put it on the circle. I still need to little bit bend it from this position. So bring your cursor here and then try to match it or superimpose it on the circle. Exactly like this. You can see here. Now you cannot identify the circle and my iris. Yes. It's exactly superimposing on each other. Okay, if you want to do it from the bottom, again you can do that. From the bottom, you just draw another arrow in the bottom, and then you just try to bend it like this. Okay, then again you select it, arrow, and try to superimpose it on the your original circle. Okay, it is still not done properly, so what you do, little bit try to rotate it. Still not done, then what you do, then you select it, I think it is done. Then try to superimpose it on the, yes, nicely done.
Yes, exactly. Yes.
Okay, now I want to do it from the left hand side so that I will get the exact circle shape of my catalytic cycle. So green. Okay, this one. Then you bend it again in the same way, and then bring it into your circle. It's okay. Exactly. So I'm satisfied with the arrow. Now I think it is properly matching or superimposing with my original circle. Now what you do, you select the circle and remove it. You can see here. I make the circle what I want, and then you put your structures in between, and you make a beautiful catalysis cycle. So it's a very useful technique. Those who are doing organometallic catalysis or inorganic reaction, even organic reactions, want to make the catalysis cycle, you can make it using this feature. Okay, so these are the little bit advanced, little bit useful technique. You can use it.
Yes, I think it will be very helpful for all the researchers who are writing proposal or who are writing manuscripts, who want to submit in a good journal. So for them, it will be really very helpful. Yes.
And I'm always there. So this is our YouTube channel. Okay, so if you want to contact me, or if you want to contact me directly, you can do that. Also, if you want to reach me, you can write email to Dr. Nayak, and I'll get it information from
Yes,
him.
and also anyone have any doubt about this ChemDraw and this, then they can also on that link, they can they are also on the comment box they can write, then definitely on that, based on that comment, we can give another suggestions, and also we can make one video also on that. The complete package we will upload it, and also the link also in the description box. I will also mention the link for part 1 and part 2, and this is the part 3. So hope we completed the whole package of a ChemDraw. So if someone will do properly part 1, part 2, and part 3, then definitely they can try able to draw any chemical structures, any molecule. They can easily draw based on their choice. They can easily draw using ChemDraw software. So thank you very much, Professor Tapas Ghatak. So thank you very much for your time. So thank you very much.
Okay. Last thing. So guys, so stay with us. Please subscribe this channel, like this channel, and please press the bell icon so that if once we upload the new video, you'll automatically get notified. Okay, so stay with us. We'll in the coming days we are going to upload very exciting and
yes, all the
research
techniques, and also all the catalysis techniques we will try to update, like FTI or NMR, everything we will try to update in coming days.
Yes.
So thank you very much.
Thank you.
Thank you, Professor.